Hi everyone. We have done with weight estimation part. To lift that weight, we have sized the wing, where the root chord, tip chord, span, area, aspect ratio, everything we have finalized at a preliminary stage, not the final stage. Okay. And we have also seen that the wing alone we cannot fly because CG should be ahead of the aerodynamic center in order to make the flight stable. Although the flying wing can fly without the tail, but you have to give the sweep back so that aerodynamic center can come behind the CG. So this way you can fly. Okay. But here we are designing the air taxi, conventional aircraft. So we have to stabilize the aircraft using tail because we have already seen that the wing alone cannot be stable flight. Okay. So based on that requirement, we have sized the tail also, and while sizing the tail, we have found out the tail area, tail span, tail aspect ratio, tip chord, root chord, and the most important part where it should be placed. That also we have figured out for a preliminary stage. Okay. What is static stability? What is dynamic stability? Static stability means inherent tendency to return to its equilibrium position when it disturbed. Okay. That is static stability. And when it attaches to the new equilibrium point, in that case it's neutral state. And when it will diverge from its equilibrium point, then it's called unstable system. Okay. And dynamic stability, that means system will take some time to reach the equilibrium position. When time comes into the picture, then we say dynamic stability. For example, if we take the pendulum, if you disturb from the equilibrium position, although it will return to the original position, but it takes some time. Okay. So that is how the dynamic stability is defined. And for example, let's say this was your equilibrium. Okay. Okay. Now you have disturbed from this equilibrium point, and now it will take this much time return to the original position. Okay. So that means if the system is dynamically stable, so it should be statically stable also. Okay. So for example, like here we have an aircraft. So that graph can be this way. Okay. This graph can have a large amplitude than that. So who decides this? Since aircraft is flying, right, and you have disturbed from the equilibrium position. For example, let's say this is a aircraft, and you want to check the dynamic stability of the aircraft or static stability of the aircraft. You have to disturb from the equilibrium position, right? So you can disturb from either by the atmosphere can itself disturb the aircraft, but you cannot wait for the atmosphere. You can generate the disturbance by deflecting the elevator. Let's say you have deflected. Okay. Now it's taking some time to reach to the equilibrium position. Okay. So which parameter, like in aircraft design, which parameter decides how fast you can dam the system? Because there is an infinite solution, right? This way the system can also be damped out. This way can also be damped out. This way can also be the damped out. So that's why I said that at the beginning of this lecture, for a static stability, I have given you the flavor. For example, like sense like what is static stability, but dynamic stability. But what is the math behind it? Which parameter plays the important role to make the system stable, dynamically or statically or unstable? That we will. I will tell you, and also I will derive the expression for the same. And before jumping to the actual aircraft, we can sample like we have considered the example of simple pendulum now. So we can consider the example of spring mass system also. where you can write you can represent the complete spring mass system using the second order mx double dot plus cx dot plus kx equal to f of t. Okay, this m is nothing but the spring mass, x is nothing but the position, x dot is nothing but the velocity, x double dot is nothing but the acceleration, and c is nothing but the damping, and k is nothing but the spring constant. So like for example, when you disturb the pendulum from this equilibrium position, who is providing the damping? It is the air which is used to provide the damping. Okay. And what is a spring? Spring constant? Spring is a stiffness. It will provide you the restoring force because T is responsible for restoring the position. So that means in aircraft something is there related equivalent to K and something is equivalent to C, and F is our disturbing force. It can be generated by atmosphere or it can be generated by the control input by elevator itself, disturbing the longitudinal. Okay, so I will tell you, like in aircraft, the CM alpha is responsible for generating the restoring force, and CMQ will provide you the damping. So depending upon this value, the graph will change. For example, if this CM alpha is very high, that means initial tendency to return the original position will be very high. If CMQ value will be very high, then the system will be damped quickly. Okay. So now when you derive the CM alpha and CMQ expression, then you should also observe what are the terms associated with, like for example, like when you derive the CM alpha, there will be lot of terms. For example, there will be lift curve slope of a wing, and then position of the aerodynamic center. So you have to observe each and every parameter, and you have to conclude yourself like which parameter plays a very important role. For example, like I have told you the CM alpha, but in CM alpha there will be a lot of terms, right? So each and every single term we will discuss, okay, in order to be very clear with the fundamentals.